Alright, so let's look at this and see how it applies to what we're doing. So we have a right triangle. So we have an initial velocity, right? That's the angle that it's shot at. And just like we did in with being launched horizontally, I'm going to break this up into its components. So horizontally, that would be initial velocity in the x, and then vertically, that would be the initial velocity in the y direction. Okay, so now let's bring the two together. So what would sine theta be using ux and uy? So sine of theta would be, so sine, like we just talked about, is opposite over hypotenuse. So that would end up being uy, so initial velocity in the y, over initial velocity. Now let's go ahead and look at cosine theta. What would cosine theta be? Alright, SOHCAHTOA, adjacent over hypotenuse, so we would end up with ux, initial velocity in the x, over u. So to make these usable, let's go ahead and rearrange these equations for uy and ux, and then we can plug them into our y and x direction SUVAT equations. So if we rearrange sine theta equals uy over u, we would say that uy equals the initial u times sine theta. Let's do the same thing for cosine. And so if we rearrange this equation for ux, so initial velocity in the x direction equals initial velocity times cosine theta. Now let's take these two equations and plug them into our equations. So first, in the x direction. If you remember correctly, we had one equation in the x direction, so Sx equals ux times t. And then in the y direction, so far there's really only been one equation that has been helpful, and that was Sy equals uyt minus 1/2 gt squared. So now let's go ahead and take this and plug it in where we see uy, and let's plug this in where we see ux. So we would have Sx equals, and now instead of ux, we have u cosine theta, and then t. Then in the y direction, instead of having uy, now we would have u sine theta. And we have, so displacement in the y equals, instead of now uy, we have u sine theta times t, and then minus 1/2 gt squared. Now these two equations become very, very important. In fact, that when these things are true, so when ax, so acceleration in the x direction, is 0, so we're ignoring air resistance, so that's going to be true. When displacement in the y direction is 0, and when ay is equal to negative g, right, we can solve all projectile motion problems. Thank you.